So today we're just going to be focusing on working with some algebraic manipulation of a non-function. This happens to be a conic section. This is either going to be a hyperbola, an ellipse, a parabola, or a circle. I'm not honestly worried about that at this point. My ultimate goal is just trying to match forms, trying to get some of the algebra out of the way. So when we talk about these different forms of conic sections, we won't have to be caught up in that algebra. So in order to complete the square, I notice I have an x squared term and an x term. I have a y squared term and a y term. Ultimately, I'm going to have to complete the square for both of these, so I'm going to do a little rearranging. I'm going to put my x squared term and my x term together. I'm going to put my y squared term and my y term together, and my constant is just going to move to the other side to get it out of the way. The next step is I'm going to take these two terms and I'm going to recognize there's a 6 as a leading coefficient. I'm going to divide out the 6 out of those two terms. If that didn't divide evenly, for example, if that had been 17x instead of 12x, I would just write 17/6 by dividing that out. In this case, 12 divided by 6, 12/6 would just be 2. I'm going to leave a space to complete the square. I'm going to repeat this process with the 4y squared minus 24y. So I'm going to factor out of 4. I'm going to leave y squared minus 6y. I'm going to leave a space. Now I've just factored, so I haven't changed the value of anything. The next step is I'm going to complete the square by filling in this blank. I get that blank by taking half of this number, which is 1, and then I square it. So 1 squared is 1. That's what I put right in there. Now similarly, I'm going to take half of this number, which is -3. I'm going to square it, and I'm going to get a 9. Now, I can't just arbitrarily add these numbers to the left side without doing something to the right. But really, I didn't just add 1, I added 6 times 1. So I need to add 6 to the other side as well to keep it balanced. In addition, I didn't just add the 9, I added 4 times 9, or 36, so I need to add that to the other side as well. So when I combine these, -18 plus 6 is -12, -12 plus 36 is 24. And on the left side, I'm going to factor. By completing the square, the purpose is to get it to a quantity squared. So I'm going to write my 6 out front. I'm going to look at my first term, which is x squared. I'm going to say x times x gives me x squared, so an x goes in that first slot. What's being squared? In the second slot, I take what was being squared in the last term, which is a 1, and take the sign of the middle term, which is a positive. For my second quantity, I'm going to repeat the process. I'm going to put my 4 out front. I'm going to rewrite this as a quantity squared. In order to arrive at that, I'm going to decide on what was being squared in the first term, which is a y. I'm going to look at the last term, decide what was being squared there, which was a 3. I'm going to take the sign of the middle term, which is a negative. What this is telling me is if I take y minus 3 times itself, I will get y squared minus 6y plus 9. Similarly, if I take x plus 1 times itself, I'll get x squared plus 2x plus 1. Now, if the 6 and the 4 weren't there, I would have a circle. I don't. Basically, it's stretching at different rates. So ultimately, we're going to find out that this is going to be an ellipse, but today, we're not worried about that. We realize that we don't have x squared plus y squared equal r squared. We have these extra coefficients in front, the 6 and the 4. So all the other forms require that we get this set equal to 1. So I could subtract 23 to get 1, but I'd have to subtract it from the other side also, which would throw off the form. What I really need to do is divide to make this equal to 1. When I do that, I'm going to divide each of these all the way through by 24. And essentially, I'm going to rewrite this. Now, multiplying by 6/24 is the same thing as taking this numerator and dividing by the reciprocal of 6/24, which is 24 over 6. Now, essentially, guys, we're just reducing this. 6 over 24 will reduce to a 4 on the bottom. Or in other words, we would have 24 over 6 or 4 on the bottom. Okay, same thing. Now, when we don't have nice, neat reducing, that's where we need to understand that we're multiplying by the reciprocal. 4 over 24 is 6. That's going to reduce to a 6. I'm essentially thinking that multiplying by 4 over 24 is the same thing as dividing by 24 over 4. So that leaves for this last term a denominator of 6. 24 over 24 is 1. That matches the form that we're looking for. We're finished with that problem. Our next problem, we'll notice, looks very similar, except now we have a positive x squared and a negative y squared. Ultimately, we're going to find that that's going to lead to a hyperbola. Right now, we're worried about just matching forms, so we're going to rearrange. Get our x terms together. Get our y terms together. Move our constant to the other side. Next thing, we're going to factor out the leading coefficient, in this case of 5, out of the x terms, and we'll have x squared minus 4x. Leave a blank. We're going to factor out a negative 3, so we have a positive y squared to complete the square with. Factor out a negative 3, we'd have a plus 2y. That's equivalent, guys, to just dividing by negative 6 by the negative 3. Leave a blank, equals negative 32. Now we've factored. We haven't changed the value of it, just the appearance, so we don't have to do anything to the right yet. Next thing we're going to do is we're going to fill in these slots. And the way we're going to do that is we're going to take half of that number, which is negative 2. We're going to square it, which is a positive 4. Since we really took 5 times 4 on that side, we're going to add 5 times 4, or 20, to the right side also. We're going to complete the square for this quantity. Half of that is 1. Square it. We get a 1. We're going to put that 1 on that side. We really put negative 3 times 1, or negative 3 on that side. So we're going to compensate. Combine our like terms on the right. We would have negative 32 minus 3 is negative 35, plus 20 is negative 15. We're going to factor as we go on the left into a quantity squared. So I'm going to go ahead and write that. To figure out what's being squared, you take what was being squared in the first term, which is x. Take what's being squared in the last term, which was a 2, because 2 squared is 4. Take the sign of the middle term, which is a negative. For the second quantity, take what's being squared in the first term, y. Take what's being squared in the last term, which is a 1. Take the sign of the middle term, which is a positive. Now, once again, I have coefficients, 5 and 3. The only thing that matches that is when it's in the form set equal to 1. So I'm going to divide all the way through by a negative 15 to get this equal to 1. You'll notice the first term when I divide becomes negative and the second term becomes positive. So I'm going to rearrange as I go. When I rearrange, my first term's negative, 5 divided by negative 15, so I'm going to write it second. Second term's positive, negative 3 divided by negative 15 is positive, so I'm going to write it first. So I'm going to have something like this, y plus 1, quantity squared. It's going to be the first one. X minus 2, the quantity squared, is going to be the second one. It's because this one's going to be a negative. The second term is going to be a positive. Now, to decide what goes on the bottom, essentially, guys, we're just reducing. 5 and negative 15 gives me 3 on the bottom. 3 into 15 gives me a 5 on the bottom. Right side we have equal to 1. Keep in mind, guys, multiplying right here when we were multiplying by 5 over negative 15. That's the same thing as dividing by negative 15 over 5. There's that -3, -3. Okay? So multiplying, same thing as dividing by the reciprocal. Same idea as we've done before. So there's my form. It's kind of interesting, but you're going to find that you're going to be repeating this process, different kinds of problems, but the same basic process for each one.